Stochastic Gradient Descent, or SGD, is one of the most fundamental optimization algorithms in machine learning and deep learning. If you've ever wondered how AI models improve over time, you're in the right place. In this video, we'll break down what SGD is, how it works, its advantages, challenges, and where it's used in real-world applications. Let's dive in. Before understanding SGD, we first need to talk about gradient descent. Gradient descent is an optimization algorithm used to minimize a cost function by adjusting the model's parameters. Traditional gradient descent, known as batch gradient descent, computes the gradient using the entire dataset before updating the model parameters. This can be computationally expensive and slow, especially for large datasets. This is where stochastic gradient descent comes in. Unlike batch gradient descent, which processes the entire dataset before making an update, SGD updates the model parameters after processing each individual training example. This allows for much faster updates and makes it a great choice for training large-scale machine learning models. The process of SGD follows three main steps. First, we initialize the model parameters, usually with random values. Second, we compute the gradient of the loss function using a single randomly chosen training example. Third, we update the model parameters by moving in the opposite direction of the gradient using the update rule. Theta equals theta minus alpha times the gradient of the loss function. Here, theta represents the model parameters, alpha is the learning rate, and the gradient represents how much the model needs to adjust based on that single example. SGD has several advantages. It is computationally efficient since it updates parameters more frequently, making it ideal for large datasets. It is also useful for online learning, where models need to continuously adapt to new data. Additionally, because SGD introduces some randomness in the optimization process, it has a better chance of escaping local minima compared to batch gradient descent, which might get stuck. Despite its advantages, SGD has some challenges. Since each update is based on a single training example, it can be noisy, leading to unstable updates and fluctuations in the loss function. The learning rate needs to be carefully tuned. If it's too high, the model may never converge, and if it's too low, training can be very slow. Another challenge is that because of the randomness in updates, SGD doesn't always settle at the exact minimum but instead fluctuates around it. There are techniques to mitigate these issues. Learning rate decay gradually reduces the learning rate over time to stabilize updates. Momentum methods help smooth out the noise by averaging past gradients. And mini-batch gradient descent, which is a variation of SGD, strikes a balance between batch gradient descent and SGD by computing gradients on small subsets of the data instead of just one example. SGD is widely used in deep learning and machine learning applications. In deep learning, it's one of the primary optimization methods used to train neural networks. It is also used in recommendation systems, natural language processing, and other AI-driven applications. Online learning systems rely on SGD because it can update models continuously as new data arrives, making it ideal for applications like fraud detection and real-time predictions. To summarize, stochastic gradient descent is a powerful optimization technique that makes machine learning scalable and efficient. It's widely used for training AI models, especially when dealing with large datasets. If you found this explanation helpful, be sure to like this video, subscribe to the channel, and leave a comment with any questions or thoughts. Thanks for watching, and I'll see you in the next video.